Hi students, in this video, we'll be working on the logarithmic and exponential functions. The questions are from the 2025 June holiday assignment. Are you ready? Let's start off by addressing some misconceptions. Let's look at these. Do you think you know what's wrong with this? Yes, you are right. The operations here should not be a times, it should be a plus. Let's look at the second one. Again, do you think what's wrong with this? Yes, you are right. To apply the logarithmic laws correctly, the base here have to be the same. So it is either base A for both or base B for both. Let's look at another one. Do you think you know what's wrong with this? Yes, it has to be only one log. What you're having here is two different log. The correct way of applying it would have to be only one log. Right, let's look at another misconception. What do you think what's wrong with this? Yes, if you look at it very carefully, you will see that this power belongs to n only. What we have here, it's definitely not the same as bracket mn close bracket to the power of x. So therefore, the person who have written this have actually applied the logarithmic law incorrectly. So what should be the correct way of doing it? Yes, you have to apply the product law first to separate them to get log m base a plus log n to the power of x base a, and then apply the power law. For this power law, you will recall log base a m to the power n So therefore, if you want to get this answer, it is only when you have log base a bracket m n to the power x. Then you can just bring down the power x. This will be correct. This is wrong. Right, let's look at the next one. What do you think is wrong with this working? Yes, if you look at this part here, this person has made the same mistake as what we have shown earlier on. So in this case here, what do you think will be the correct way of doing it? Right, so from the second steps, if you want to do it this way, by bringing ln to both sides, then you will have to apply the product law to separate them. Simplify ln 30 minus ln 20 to get ln 30 over 20. And also to apply the power law for this. And ln e is 1 because ln e is basically log base EE. So that gives you 1. So x will be ln 3 over 2. An alternative way would be just make e to the power of x the subject, and then to bring ln to both sides. So that will save you a lot of trouble. So the first 2 slides are important because it address some misconceptions made by some students. Right, let's solve some problem. Let's look at these questions. You're given a graph y equals to log x base a, and we have 3 points that passes through this graph. What does it mean? Yes, it means the points lie on the curve. It means I can substitute x to be 8, y to be 3, or x to be 1 to y to be b, or x to be c and y to be negative 2 into y equals to log x base a. Alright, how do I get that? So this is called the logarithmic form, and I can actually convert the logarithmic form into index form. First of all, identify the base of your logarithmic equation, which is a here, and a to the power of the answer equals to 8. But you can write 8 as to the power of 3. Why do you want to do that? Because we want to make the power the same on both sides. A to the power of 3 equals to the power of 3, and if the powers are the same, then we can conclude that the base will be the same. So therefore a is equals to 2. And we can use the second point, which is 1 comma b. Right. We do the similar techniques that we've done earlier on, convert from logarithmic form into index form. Here your base is 2, so 2 to the power of b equals to 1, and we can actually write 1 as to the power of 0. Anything to the power of 0 gives you 1. So from there you can have the same base 2, so therefore b is 0. Let's look at the third point. Right, let's do the same. So the power here is 2, so 2 to the power of negative 2 will gives you c, and 2 to the power of negative 2 is basically 1 over 2 squared, and that gives you 1/4. So this question is relatively manageable. 5b, we asked to sketch the graph of y equals to log x base a. Now x has to be more than 0, so when the x is equals to 1, two to the power of y is equals to 1, 2 to the power of y is equals to 2 to the power of 0, y is equals to 0. That explains how I get this point here. 1, 0. Alright. And since your x has to be strictly more than 0 for log x base 2 to be defined, you'll see that the curve here, this part of the curve, it will not touch the y-axis. And when the x get bigger, your y will get bigger. So that explains this part of the curve. Let's look at the next questions. So for the next questions, we're asked to solve, in part A, we're asked to solve a logarithmic equations. And if you were to examine the bases, you will see that they have different base. The first one, the first log is base 2. The second one is base 16, right? So because they have different bases, we cannot apply the product law. So what we need to do is we need to convert either 2 to base 16 or 16 to base 2. But it's easier to convert a bigger number, change the base of the bigger number to a smaller one. So let's do a recap on how to apply the change of base. Supposing if I have log base A, B, if I'm going to change it to log base C, so this is how I'll do it first. Right, so the original base A go to the denominator and B will go to the numerator. So this is how we do it. So we're going to change this to base 2. Okay, right. And 16 can be expressed as 2 to the power of 4. Log base 2 16. 16 can be written as 2 to the power of 4. And then I can apply the power law by bringing the 4 to the front. Log base 2, log 2 base 2 will give you 1. So that will be 4 times 1 gives you 4. So that explains how I get this answer here. And the next step is I'm going to use substitution. Substitution is a very wonderful technique that can be applied to solve many problem sums. So I'm going to replace log x base 2 with letter A, and this one here can be written as 1/4 times log base 2x over 1. So that gives you 1/4 times a over 1. A over 1 is just a, so that gives you 1/4 a. So a plus 1/4 a will give you 5 over 4a, and making a the subject will give you -2. But remember, a is a substituted value for log x base 2. So you have to replace it with log x base 2. And here we can actually use what we've learned earlier on, convert it into the index form. Alright, look out for the base first, which is 2. 2 to the power of your answer, -2, gives you x. So to the power of -2 is basically just 1 over 2 to the power of 2, and that gives you 1/4. That explains our answer here. Right, let's look at part B. So for part B, we're given again another logarithmic equation. In this case here, I'm supposed to express z in terms of y. It means that I have to get rid of my log, which means I have to apply the laws we've learned. So there's a misconception here. Alright, this is not equal to log z plus log y. Okay, it is not equals to that. What we can do is to apply the quotient rule here. And now we have log on both sides. We can just get rid of it to get z over y equals to z plus y. Going to multiply y on both sides of the equations. So that will give you z on the left, zy plus y squared on the right. And we're going to make z the subject. So I need to combine terms that have the variable z together. So I have to bring zy over to the left side. That will give us z minus zy equals to y squared. Factorize the z, and that will give us z equals to y squared over 1 minus y. And that is part I. So for part 2, we asked to state the range of values of z and explain clearly why y must be more than 0 and less than 1. Alright, so if you were to look at your logarithmic equations again, you will see that for any log to be defined, the values of y must be positive, more than 0. The base a must be more than 0 and not equals to 1. So therefore, for these equations to be defined, my log z, my z has to be more than 0. And if z is more than 0, remember in part I have made z the subject. Z is equals to y squared over 1 minus y. And if z is more than 0, it means y squared over 1 minus y must be more than 0. Now we all know that y squared is more than equal to 0 for all values of y. So that will make 1 minus y positive, because a positive divided by positive then will give you a positive value. So 1 minus y must be more than 0. And with that, you will get y less than 1. Okay? And if you go back to this equation again, for it to be defined, my y has to be more than 0, right? So we're going to combine y more than 0 and y less than 0. And you'll get y is more than 0 and less than 1, which is what the question requires us to explain. Let's look at the next questions. The next questions involved the exponential functions. So we're supposed to show that this exponential functions is only one solution. It means we're supposed to find the values of x. And there's only one value of x. And this particular value of x, we need to correlate to two significant figures. Okay, let me show you the wrong approach carried out by some students. Right, we know that e to the power of x is a good friend of ln, because ln e basically is equals to log base e that gives you 1. Right, so some students would just bring ln to both sides. Okay, and here we can apply the power law, no problem. You can split it into ln 2 plus ln e to the power of negative x. And then you will find that you get stuck here. You just cannot proceed. Why you cannot proceed? Because surely this is not equal to ln 3 e to the power of x plus ln 5. It is not equal, because the operation here is a plus, not times. Okay, so you cannot do that. So if that's the case, then how do you go about solving this kind of exponential equation? Yes, for this sort of exponential equations, we have to use the substitution method. Okay, so the correct approach is to let e to the power of x to be a letter A or B or whatever letters you fancy. And then you just replace e to the power of x with a and e to the power of negative x with 1 over a, multiply by a throughout to form a quadratic equations. Factorize it, and you will get two values of a, which is 1/3 and negative 2. Now bear in mind that your a is a substituted value for e to the power of x, so you have to replace it with e to the power of x. Okay, in this case here, then to find the values of x, you can bring ln to both sides. So that will give you x ln e equals to ln 1/3. X will be ln 1/3, which is negative 1.1. How about the other value? When a is negative 2, e to the power of x is equals to negative 2, which is rejected because e to the power of x is an exponential functions. Basically, always if e to the power of x is always more than 0. So therefore, e to the power of x equals to negative 2 will not exist. So it has to be rejected. Alright, let's look at the next one. So for the next questions, you are given equations involving the indexed notation. 6 to the power of x equals to 5 times 3 to the power of x plus 1. And you are asked to find the values of x in logarithmic form. Right, so here again, some student may jump to bring log to both sides. And if you do that, you'll find that it's possible. Okay, it's alright here to bring LG to both sides. So what I've done here is just apply the product law. This is a times. So apply the product law to separate into two different logs. Apply the power law here. Open up the brackets. Why open up the brackets? Because I have here x log 6 and that is x log 3. I have to bring all the terms involving x together. And log 5 and log 3, I can combine them to be log 15. On the left hand side, factorize of x out. Log 6 minus log 3, I can use the quotient rule to convert it into log bracket 6 divided by 3. That gives you x log 2. You can do it this way. Sure, you can do it this way. But I'm going to show you another way. And what is another way of doing it? Is to relate this to the topic on indices. Okay, so what are the rules we have learned in indices? Okay, I'm missing an M here. Right. So far, these are the basic rules we have learned in indices. So we can use, for example, this one here to separate this guy. Alright, so these are all the recaps. Usually I will just show you all the topics that are connected that you need to apply to solve the questions. Okay, so as what I've just mentioned, we can use a to the power of m plus n to separate 3 to the power x plus 1 into 3 to the power x times 3 to the power 1. And of course, 5 times 3 will give you 15. Right, and you see that I have a term, I have to group these two terms together. And I can apply this one to get 2 to the power of x. Oh, from this to here, from these steps to these steps, I actually divide by 3 to the power of x on both sides in order to combine my 6 to the power of x with 3 to the power of x. So I have 2 to the power of x equals to 15, and then I bring common log to both sides. Okay, so this is another way of solving 2a using the rules of indices and also the logarithmic laws. Otherwise, you can use the first method I've shown you. Let's look at the next part of the questions. In these questions, we are asked to express the logarithmic equation as a cubic equation in x. What it means is that I just have to remove all the log, and the answers will be in the form ax cubed plus bx squared plus cx plus d equals to 0, where a, b, c, d are constants. So if we were to examine the logarithmic functions, we can see that we don't have the same base for the both logs. So we would have to change it to the same base. So as explained earlier on, it's easier to change a bigger number to a smaller number. And here I have a recap on how we can actually apply the change of base. Right, if you want to change it to base c, basically you just have log base c at the numerator, log base c at the denominator, and then the original base, which is a, will go to the denominator, b will go to the numerator. Alright, so this is what we're going to do. And of course, not to forget the logarithmic laws that we have to apply. Basically, if you have log bracket a, b, it will give you log a plus log b. And you have log bracket a over b, that will give you log a minus log b. Right, so let's go on to carry out. Yeah, and that is the power law. Let's go on to carry out what we have discussed. Right, and log base 3, 9, you can actually express 9 as 3 squared. And here I can apply the power law by bringing the 2 to the front. Log 3 base 3 is 1. 2 times 1 gives you 2. Alright. Let's look at the next step, which is exactly what I've just explained. Right, and divide by 2 has the same meaning as half. Here it means log base 3 x plus 2 over 2 has the same meaning as half times log base 3 x plus 2 over 1. Alright, so the next step is I still cannot apply the product rule here. To apply the product rule, you realize that the coefficients of your log b and log a here, it has to be 1. I still have this half here that's in the way, so I have to apply the power law. Oh no, I multiply by 2 throughout first, okay, 2 throughout because it's easier with a whole number than with an integer. And then I'm going to bring this guy out to get x squared. So this one, I skip a step here. What I should be having is log base 3 x to the power 2 plus log base 3 bracket x plus 2 equals to 4. And now I can apply the product law to combine them. Right, there are two ways of doing it. One way is to write 4 as 4 log 3 base 3 because log 3 base 3 is 1, and then you apply the power law so that it can make log 3 on both sides. And since we have log base 3 on both sides, then of course the whatever that's inside here has to tally, and that gives us a cubic equation as what the question requires us to find. Another way is if you are very good at converting from logarithmic form into index form, then you can just look up for the base here, which is 3 to the power of 4 will give you x squared bracket x plus 2, and you will still get the same answer. Alright, before we do question 6, let's do a recap. Log a base a is 1. Alright, basically your a must be more than 0. So for questions 6a, we are given a logarithmic equation and we are asked to express it as a quadratic equation in x, which is a similar kind of questions that we have dealt with in the earlier questions. Earlier questions, we are supposed to express it as a cubic equation. Here, we're supposed to express it as a quadratic equation. So in other words, the answer that you'll be getting will be in the form ax squared plus bx plus c equals to 0, where a, b, c are constants. And then we need to explain why there are no real solutions. Basically, after getting the quadratic equation, we're supposed to factorize it to find the values of x. And we need to explain why there's no real values of x. Alright, so let's express it as a quadratic equation first. So let's recap with all the logarithmic law. Okay, so the first step, you see that we are very lucky because the base that we have here are all base 2. So there's no need to apply change of base here. All we need to do is to apply the power law, and this one here will be similar to the quotient law here. And since we have log base 2 on both sides, we can just remove it. And do a cross multiply. And that's how we arrive at getting a quadratic equation in x. So the next thing is that we need to solve it. So there are two ways of solving it. Either you use the quadratic formula to find the value of x, or the better way is to use discriminant. Discriminant meaning the value for b squared minus 4ac. The value will tell us if the quadratic equation has real solutions or not. And we end up getting negative 64. And negative 64 is less than 0. And if we were to examine the quadratic equation, the coefficients of x squared is 1, which means if you were to sketch the curve, it's a U-shaped curve. And since it has unreal solutions, no real roots for b squared, no real solutions, no real values for b squared minus 4ac, this will be a U-shaped curve that's entirely above the x-axis. So therefore, the equation has no real solutions. Right, let's look at the next part of the questions. To do the next part of the questions, we will need to apply this law. And how do I get it? Basically, if I'm going to change it to log base b, I'm just applying the change of base rule here, and log b base b is 1. Alright, so we can actually do away with these steps by just remembering that it will be a fraction, and then you interchange the position of these two variables. Okay, so this is exactly what we're going to do. But before that, we need to rewrite these fractions into two fractions, so that I can change this to base x. And why do I want to do that? Because the first log that you're given is in base x. Right, so we have, if you cannot visualize this, you can actually use substitution method. Substitution method is a very powerful method. If you're going to replace log y base x with a, that will give us a squared, right? And this will just be a. So I have a squared times a, and that gives me a cubed, right? So I'm going to replace a with log y base x. So this is how you get it. Make sure that you put the bracket there. It's very important. Why is it important? Because log x y to the power of 3 is actually just 3 times log base xy, which is just 3a, not a cubed. So it's very, very, very important that you put the bracket there. Alright, so we have a cubed equals to negative 8. So how do I find a? Yes, basically I just cube root negative 8. And cube root negative 8 will give me, what does it give you? Yes, it gives you negative 2. And you can just apply the change it into index form. X to the power negative 2 is just basically 1 over x squared. And that's how we do it. Let's look at the next question. In this question, you're given the hint, and the hint is to replace 2 to the power of x with the letter u. And having done that, you're asked to express the equation in terms of u. Let's recall, in the chapter on indices, we learned that a to the power of m plus n is equals to a to the power of m times a to the power of n. And we're going to use this concept to simplify these two terms. So what is 2 to the power of 2x? There are two ways of writing 2 to the power of 2x. You can write it as 2 to the power of x multiplied by 2 to the power of x again, because x plus x will give you 2x. Or you can write it as 2 to the power of 2x equals to 2 to the power of x to the power of 2. This one will derive from this rule that we've learned. Right, so with this, we're going to simplify it further. And of course, 2 to the power of negative 1 is half. The next thing is that we're going to replace 2 to the power of x with the letter u. We're going to multiply every term with 2 to get rid of our fraction half. And we end up having a quadratic equation in terms of u. And this is exactly what we are required to do in part I. And in part 2, we're asked to solve it. So to solve it means we have to find the values of u, which is a substituted value for 2 to the power of x. Ultimately, what we need to find are the values of x. But we have to find the values of u first. So we can factorize it to get u equals to 6 or u equals to 2. And remembering that u is a substituted value for 2 to the power of x. Right, so the only way that we can find the values of x here is to bring log to both sides. Apply the power law. Divide by log 2 on both sides. And since we're asked to express the answer to one decimal place, you would get x equals to 2.6. How about the other value when u is equals to 2? Let's see what happened. We end up having 2 to the power of x equals to 2, but 2 can be written as 2 to the power of 1. And since both of them have the same base, that means they would have the same power, which gives us x equals to 1. So this is how we solved 11 part 2. Let's look at the last part of the questions. We're asked to explain why the given equation has no solution if the values of k is more than 8. So we're going to generate a quadratic equation like what we've done in part I in terms of u and k. We're going to multiply by 2 throughout. So which chapter have we learned that would allow us to determine any equations with what kind of roots it has? A given equation can has no real solution, can has no real solution, meaning no real roots, can have real and repeated roots, it can have real and distinct roots. So do you recall which chapter we have learned that? Which concepts does it involve? Yes, it's under the chapter on quadratic inequalities, where we use the value of the discriminant, values of b squared minus 4ac, to help us determine what kind of roots an equation has. If the value of b squared minus 4ac is less than 0, then basically the equation has no real solution. If it's more than 0, it has two real and distinct roots, meaning two real and distinct solutions. If it's equal to 0, it means that it has two real repeated roots or two real repeated solutions. So we're going to use that. So we're going to substitute a to be 1. A basically is the coefficients of u squared. B is negative 8. And the constant c is 2k. And like what I have explained earlier, if the equation has no solution, it means that the value of b squared minus 4ac is less than 0. So we're going to use this concept. We're going to let b squared minus 4ac less than 0, meaning we're going to let 64 minus 8k to be less than 0. And with that, we will end up getting k more than 8, which is what we are required to do in part 3. In this particular question, it is a problem sum. We are told that the number of bacteria in a culture doubles every 3 hours. What does it mean? It means when t is equals to 0, supposing the number of bacteria is n, 3 hours later, meaning t equals to 3, then the number of bacteria will become 2n. And if it's t is equals to 6, another 3 hours later, it will be 4n. So on and so forth. This is what it means. So we're given an equation that represents the relationship between the number of bacteria when t is 0 and also the number of bacteria when t is equals to t hours. So when t equals to 0, the number of bacteria is given by n to the power of 0, and the n to the power of 0 is the bacteria that is present, which means n is represented by n to the power of 0 when t is 0. So when the time is equals to 3, because it's 3 hours later, then what we are saying is the number of bacteria is no longer n to the power of 0, it's become doubled. So it becomes 2n0. So we're going to substitute this n with 2n0, and then we'll see what happens. So the n subscript 0 will be cancelled off, leaving only 2 equals to e to the power of 3k. And we're going to bring natural log to both sides, apply the power law, ln e basically is just 1 because ln e is just log base e, and that gives you 1. So we have 3k equals to ln 2. So k will be ln 2 divided by 3, and that's approximately 0.231. And that's how we solved question 13. Right, let's look at the next question. The next question involved baby food. So this baby food is heated in a microwave to a temperature of 80 degrees Celsius, and then subsequently cools in such a way that its temperature T degrees Celsius T minutes after removal from the microwave is given by a certain equation. The equation is T equals to 20 plus A e to the power of negative KT, where both K and A are constant. So for part I, we are asked to explain why A is equals to 16. Right, So when t is equal to 0, all right, you have to understand that t represents the time after you remove the baby fruit from the microwave. Right, so when t is equal to 0, that means the baby food is still in the microwave with a temperature of 80 degrees Celsius. So we're going to substitute that into the equation given. And if you substitute t to be 0, e to the power of negative k times 0 will give you e to the power of 0. And e to the power of 0 is equals to 1. So therefore, you will end up getting 20 plus a equals to 80. So therefore, a is equals to 60, which is what we are asked to explain in part I. So when t is equals to 1, that means 1 minute later, that means after bringing the food from the microwave, leave it outside the microwave, 1 minute later, of course, the food will get cooler and the temperature will drop from initial of 80 degrees Celsius to 65 degrees Celsius. And in part 2, we asked to find the values of k and to correct the answer to 3 significant figures. So this is what we're going to do at t equals to 1. You end up getting 20 plus 60. We've already found a to be 60 in part I, so we can replace this value here with 60. So you will get 20 plus 60 e to the power of negative k. Why negative k? Because you substitute t to be 1. So negative k times 1 will give you negative k equals to a temperature of 65 degrees. So we can simplify further. Make e to the power of negative k the subject before you bring natural log to both sides. Apply the power law, and you will get k to be approximately 0.288, expressed to 3 significant figures. So that's part 2. Right, so part 3 is important because you're going to feed the baby with food, and the food cannot be too cold, it cannot be too hot. If it's too hot, it will burn the baby's mouth. If it's too cold, then it's not tasty. So the question says that if you leave the food out for 4 minutes, is it safe to give it to the baby? So anything that's less than 40 degrees is considered a safe temperature to give the food to the baby. So what we're going to do is we're going to let the temperature to be less than 40 degrees, because anything that's less than 40 degrees is a safe temperature to give to the baby. And you bring natural log to both sides, and we see that t is less than 3.81 minutes. In other words, if you were to lift your foot for anything less than 3.81, the temperature will be less than 40. And of course, if you leave it for 40 minutes, the temperature will drop even further, right? Drop even further, even lesser than 40, which is, of course, a safe temperature to give to the baby. So what we have calculated here is t is less than 3.81, so it could be 3.80. And since 3.80 is less than 4 minutes, so therefore it is safe to give the food to the baby 4 minutes after removal from the microwave. Right, let's look at the last question. So the last question is 5a, right? Some of you may be very tempted to do it this way because you see e to the power of x, and we understand that e to the power of x is a good friend of natural log. So you may be very tempted to do this. Right, and this one here, we can apply the power law. And you can bring the power down. Ln e will be 1. realize that you can't continue any further because there's no laws given to simplify this part here. You only have ln bracket a times b. That gives you ln a plus ln b. You don't have one for ln bracket a plus b. You don't have one for it. So you're stuck here, right? So you cannot proceed anymore. So if you have ended in such a situation, it means that the approach that you have taken is not correct. So you will have to change another method. So what is the other method that you can use here? Let's take a look. Yes, the other method we can use is the substitution method. Remember what I've mentioned earlier? The substitution method is a very practical and very useful method that we can use to solve a lot of problems. So we're going to replace e to the power of x with the letter b, and you end up getting a quadratic equation in terms of b, which you can factorize it. But remember, b is the substituted values for e to the power of x. So whatever values you get for b, remember to equate it to e to the power of x. Now, why is this value being rejected? Because if you're going to replace b with e to the power of x, you end up getting e to the power of x equals to negative 1.5. And of course, it have to be rejected because e to the power of x is an exponential function which is more than 0 at all times. Let's look at part b. Right, so for part b, we will have to use the change of base concept. Why do we need to do that? Because if you look at the question given, this is base 2, this is base 2, but this one here is base 8. So I'm going to change this to base 2. So therefore, 1 over log base 8 2, if you were to compare with what I have here, b is 8, a is 2, and this will give you log base 2 8. You just interchanged the numbers. And this is exactly what we're going to do. Right, but you still cannot use the product rule for this because I have to change 1 to base 2 as well. So base 2 log 2 base 2 is 1. So with that, I have all the logs in terms of base 2 and I can apply the product law. Right, before we do the last part of the last questions, we need to revise on some concepts. If you look at what I have on the screen, I have a curve and a straight line. So if you look at the first diagram, the first curve given to you is y equals to x squared minus 5x plus 6, and then the straight line is y equals to x plus 1. Right, so graphically, we can see that the x coordinates of the intersection points are 1 and 5. That means x equals to 1, x equals to 5 are the solutions to the intersection point of the curve and the straight line. If you were to solve it simultaneously, right, this is how you do, right? You equate x squared minus 5x plus 6 equals to x plus 1. You simplified it to get a quadratic equations, right? And then you factorize it and you get the solutions. So the x values, you see that x equals to 5, x equals to 1 are actually the x coordinates of the two intersection points that you get when the curve intersect the line. If you look at the second diagram, all right, you're given a curve x squared minus 4x plus 4, and a straight line 2x minus 1. And if you simplify it, what do you realize? Yes, you actually end up getting the same quadratic equations that we have got on the left. And the solutions are the same, x equals to 5 or x equals to 1. Of course, the y coordinates will not be the same because we're talking about different curves, different lines. But you see that the x coordinates are the same because we are actually dealing with the same quadratic equation. This one here. If you look at the third diagram, okay, I have a different curves and a different straight line. But if I simplified it, you see that, yes, I get back the same quadratic equation. So obviously when I solve it, I would get the same x coordinate, right? So what does this example show you? It shows you that from a given quadratic equation, okay, from a given quadratic equation, this one here, this quadratic equation, I can actually split it into a curve and a straight line, depending on what I want the curve, the equations of the curve, or the equations of the line to be. I can let it be x squared minus 4x plus 4, y equals to x squared minus 4x plus 4, and y equals to 2x minus 1. I'll end up getting the same quadratic equation. I can actually split it up into x squared minus 3x plus 4, y equals to x squared minus 3x plus 4, and y equals to 3x minus 1. Or I can split it up to be y equals to x squared minus 5x plus 6, and y equals to x plus 1. In each of these cases, I will end up getting the same solutions, the x coordinate, because I'm solving the same quadratic equation, which is x squared minus 6x plus 5 equals to 0. So this concept is important. Why is this concept important? Let's look at the last part of the last question. Right, so let's say I'm given x squared minus 6x plus 5 equals to 0. I want to find the graphical solutions to these quadratic equations, where I need to draw a straight line, where this straight line will intersect a quadratic curve on the same axis. And the quadratic curve given is y equals to x squared minus 5x plus 1. Then what would be the straight line be? What would be the straight line equation be? So in other words, I have a curve which is y equals to x squared minus 5x plus 1. Right, so the curve will be this way. Right, so I need to draw a straight line such that when this straight line intersects my curve, the x coordinates of the intersection point will be the solution to this quadratic curve that I'm asked to solve. Right, so how do I go about doing it? How do I go about getting my straight line equation? Right, so we have to work on what is given. So what is given is x squared minus 6x plus 5 equals to 0. Okay, and I need to manipulate it so that on one side of my equation, I will get x squared minus 5x plus 1. So to get x squared minus 5x plus 1 means, to get minus 5x means I need to plus 1x on both sides, right? 1x is just x lah, plus x on both sides. So here I would get x squared minus 5x plus 5 equals to x, right? And then to get positive 1 means I will need to minus 4 on both sides. Because 5 minus 4 then give me 1, right? So I would end up getting x squared minus 5x plus 1 equals to x minus 4. So can you see that your x squared minus 5x plus 1 is the equations of the curve? This one is your equations of the curve. So the straight line, the equations of a straight line will be this one here. Which we are required to find. Okay, so this is the concept that we need to have in order to do the last part. All right, so let's do some recap. Ln is actually log base e, and we also need to use the power law, and also need to learn how to convert from logarithmic form to indexed form. All right, so let's look at what we're given. So this equation, it's similar to our x squared minus 6x plus 5 equals to 0. We need to split into two equations, right? So I've converted ln to log base e. Why do I do that? Because the equations that I need to get on the left-hand side is in terms of e, exponential function. So therefore, I need to convert ln to log base e. And from there, I need to convert it to the index form. Oh, before I convert it to index form, let's bring the power 2 down first and then divide by 2 on both sides. Okay, so to convert it to index form, look out for your base. The base is base e. So e to the power of x over 2 will be equals to 2x plus 7 over 3. Alright, so we are not done yet. If you look at what you're supposed to get, we need a 3e to the power x over 2. So I need to multiply by 3 on both sides. And I need a positive 4. So how do I get the positive 4 from the left-hand side? So negative 7, I need to add something to get 4, right? So I need to add 11 because negative 7 plus 11 give me 4. So I need to add 11 to both sides. Okay, so we see now that we have two equations. Okay, this one is one equation, and this is the straight line that you need to draw. Okay, when the curve and the line intersect, the x coordinates of the intersection point satisfy both the equations. So therefore, the straight line that we need to draw will be the solutions to x equals to ln bracket 2x plus 7 over 3 to the power of 2. So therefore, the straight line to draw will be y equals to 2x plus 11. So that ends the whole assignment. Okay, happy learning.